Alrighty, hey honors chemistry. So I wanted to just make a quick video about the next digital lab report so we're nice and understanding and all clear. So you'll find in the Google Classroom something that looks like this. When you click on it, it'll automatically ask you to make a copy. You should delete the copy of and put your last name, first name, and then the lab report title. This lab report is title is on the handout, or you could just say AgNO3 and NaCl. There's a purpose. I would suggest doing the purpose after you do everything. We'll talk about it in class. Why do you think we added known amounts of reactants together? What would be our purpose? We'll talk about that later. For the data, it's a little bit different, but I told you to record these things. It's a little bit different than on your handout. So empty beaker is very important, so that's good. You're going to get the beaker and AgNO3, and even though this is a mass, it has a volume too. I'm going to help you convert that volume to the actual mass. So I'm going to have a conversion. I'm going to tell you what mass basically you're going to have here just to help you out. Then you're going to have later on, you're going to have your empty beaker and then the AgCl that's in there, that's in the oven. And then we have beaker number 2. And the whole purpose of beaker number 2 is just for NaCl. So you have beaker number 2 and NaCl. So this difference can help you get the mass of NaCl. And then later on, you have like the filter paper. And if some stuff went through your filter paper or is on the filter paper, you'll have the filter paper and AgCl. And then if you have just filter paper, if you subtract this difference, you'll get the mass of AgCl also. Okay, then for your calculations table, the AgNO3 used in this experiment, I'm going to help you out. If you give me the volume that I gave you, I'll help you tell you what grams, and then you can easily convert that to moles by dividing by the molar mass. And I'll leave this note in here. I'm going to write divide by molar mass. So I need a divided sign. Divide by molar mass. Okay, just to remind you. Okay, for NaCl, you got that from beaker 1 and from 2 blank or empty and beaker 2 with NaCl. For the AgCl, you're going to get the total in 2 steps. There's an AgCl that's left in the beaker, so you need to get the mass of the empty beaker and then the mass of AgCl and in the beaker, and that difference is what's going to go here, and you have moles. Then there may or may not be some AgCl that's on your filter paper that's drying. You're going to have that little bit of amount on here. And the way you're going to get that is by subtracting off the filter paper, and then you can convert that to moles. And then if you add these two together, if you add the masses together or you add the moles together, they will go in these columns. So, for example, if you got 0.01 grams and 0.005 grams, then that could easily be 0.015 grams. And then whatever these moles corresponds to, if this was like moles A, and moles B, this would be A plus B, okay? So just an example of how you could do those calculations, all right? And then for your ratios, you're just gonna take the moles that you have here, right? So if I label this, right, if this is A, and then this is B, and then this is C, okay? Later on, I'll get rid of that. If I want you to get the ratio of moles of AgNO3 to NaCl, basically what I'm asking for is I want B over A. And this you're also going to put in the spreadsheet. Okay? Same thing with this one. If I want AgNO3 to AgCl, that's going to be A over C. And you're going to put in the spreadsheet. And so, of course, as I've been doing this, there is a spreadsheet. It is copied and pasted. I want you to put the link here of your lab report. You're going to put moles of silver nitrate, moles of sodium chloride, and moles of silver chloride, and it's going to do the calculation for you, so don't worry about that. All you're doing is putting your moles data from that table here. And then, moving on, it wants you to construct a Vca table, but this time I made it easier for you. I'm going to delete this for later, because I think you're all copying this. But to make it easier for you, I kind of already made your Vca table, right? So you're welcome, because I know some of you are like, oh, I have to make a table, da-da-da. I helped you out. We're going to do 2 different Vca tables. So you are just putting your answer to 1A, which I labeled it already, 1A in moles, right here in the Vca table. And then your change in after, your after should be about 0. right? We're going to assume all of the AgNO3 is going to be used up, and that's what I tell you. And later on, I'm going to tell you that it's a limiting reactant. And then you're going to do mole ratios, and what's nice is everything here is a 1-to-1 mole ratio, so these numbers are all going to be the same, basically. So if this was 0.05 moles, this would be 0.05, 0.05, da-da-da. I'm making that number up. So this is a nice one because it's all 1-to-1 ratio. And then whatever moles you get here is your theoretical yield. And then I tell you to calculate your percent yield, and I'll have another video to help you out if you forgot. But what you're going to do is the amount of AgCl you measured in 1B, all the way up here, right? Oops, does that say 1B? 1C, my bad. I changed it. So this I call 1C. The amount of AgCl that you have here is your actual yield, okay? That's what you actually got. So the stuff that you weigh out or take the mass of from your beaker and your filter paper, that's your actual yield. The stuff that you calculated in question number 2, that's how much you should have got. That's your theoretical yield. So, and then you have to convert that to moles. So I'll write a note here for yourself and say convert to grams, So theoretical yield, you'll have moles, and then convert to grams. And that's your theoretical. And then if I want my percent yield, you're going to do actual over theoretical times 100. Now, for the 4th calculation, this is not going to be due until Friday because we're going to talk more about limiting reactants and excess reactants. So you could leave this blank for now and return to it. And when I check your lab reports the following weekend, should be all in there. But we'll talk more about this later. But you're going to be using both your amounts in moles. Remember, the only thing that goes in the Vca table is moles. You're going to be using both your amounts of moles in this table. And then I'll show you how to do that. Then there's really only 2 or 3 post-lab questions. I changed them. This is completely different than your handout. I changed them because I changed the direction. The real purpose of this lab is I wanted us to experience limiting reactant calculations and procedures. So you're just going to follow through. Here is the theoretical balanced chemical equation. It's all 1-to-1 mole ratio. So basically, these are just going to be 1-to-1. And then you're going to look at your ratios that you got up here and see if it's greater than, less than, or equal to the theoretical here, which should be 1-to-1. So is it greater than 1, less than 1, or equal to 1? And then it says use the reactant ratio. Are there more moles of silver nitrate or more moles of sodium chloride? So basically, if your ratio is greater than 1, there's going to be more moles of silver nitrate. If it's less than 1, there's going to be more moles of sodium chloride. And then off of this, if your ratio is greater than 1, we're going to say that AgNO3 is going to be excess. If it's less than 1, we're going to say NaCl is in excess. And you could read this here. It says, theoretically, this reaction should have occurred in 1-to-1 mole ratio. For this reaction, whichever substance there are more moles of, it would be labeled as the excess. So whichever one there are more moles of, it's the excess reactant. Whichever one there are the less moles of, that's going to be known as the limiting reactant. And then 2 and 3, I took and derived from your next unit test. So being able to answer these questions, it's kind of a multiple choice with a justification. So which of these are not conserved in a reaction? One of these is not conserved. And then here is a sample calculation that I do want you to do. This is related to everything we've been doing, and it's just what's going to be similar to your unit test. So I have data here. I want you to write the balanced chemical equation. It says I put copper wire and silver nitrate. I think you've done this reaction before. I put copper wire and silver nitrate, and I get silver and copper 2 nitrate. So write a balanced chemical equation for the reaction. From the mass of copper reacted, here's copper wire before and after. Remember, before and after, if I subtract those two, that's how much reacted. Throw that into a Vca table, use my moles of copper to figure out many moles of silver I could get, and then determine the actual yield of silver, which is really just right here. I have empty beaker, and then I have beaker with silver. This is my actual yield, the difference between my beaker and silver. And then percent is going to be your answer from C over your answer from B times 100. It's your actual over theoretical times 100. All right, so this is the gist of the entire lab report. I kind of walked you through what I would like you to do. If you need to slow down this or figure it out, I tried to speak fast so you could fast through or power through. If you have any other questions or concerns, we will talk about this more in class. So let me know.